Right, this week, guys, I want to talk about vectors. Okay, some of you might have heard this from a recent movie called Despicable Me. Great movie. We'll talk about that in a little bit. But this is just going to be one lesson I want to break up into 3 different videos, and it would normally be 3 different days in class. And this is going to be the only thing that we try to hash out this week. This idea of vectors. So just some general information about vectors. It says it's a specific quantity drawn as a line segment with an arrowhead at one end. So I'm going to pick on this vector, this blue vector right here. Okay? And so that blue vector could represent a lot of stuff. It could represent force, gravity. We're going to see in a couple of videos from now the speed of an airplane. It could represent a lot of stuff. All right, physics really goes in deep with this. And if we had more time, I definitely would as well. But we're running short on time right now. So the first thing I want to point out is what I'm going to call the initial point. The initial point is this x1, y1. It's going to be where my vector starts at. Okay, so imagine that this was just like the flight of an airplane taking off right here. And so the initial vector would be where the plane started at whatever time, and then the terminal point would be where the plane ended after a certain amount of time. Maybe it's 7 seconds, 7 minutes, I don't know. And so my terminal point is going to be that point at the end, which is I'm going to denote as x2, y2. Now we're interested in several things with these vectors that we're going to talk about, and it will spill over a little bit into my talk next week on polar coordinates. One of the things I'm going to be interested in is the magnitude. Okay, so if this vector right here, I'm just going to call it v for vector. If I'm looking at finding the magnitude of v, I'm going to put v in jail, like so. Okay, and all that's going to tell me is going to be how long the vector is. How many units does it take up? And so, as you can see, we can easily do distance between 2 points. But hopefully before the end of the video, we can find an easier way to do this after we do some moving around. Okay? Now, I'm not always going to use the same notation on this. I'm going to introduce several notations on vectors so that if you see it later on, you'll be good with any of them. Okay, so sometimes it's just a lower case, and that's going to be boldface type. So I can't really write in boldface on this other than writing it twice. But yeah, whether I do vector v, u, w, if it's bold, more bold than the regular type, we assume that's a vector. A little bit easier for me if I'm talking about a vector is if I just put an arrow over it. Okay? And so that would also denote that I'm talking about a vector. Now, if I'm given an initial point and a terminal point, like I was C and D on the last one, I could actually rewrite that vector with its initial and terminal point, writing the initial point first, the terminal point second, Q, and then drawing an arrow over it so that the arrowhead is over my terminal point, which is where point Q is. All right? Now, I'm going to be interested in putting something in something called component form, is what I'm going to call it a lot. That's what point 3 is talking about. Component form. They also call it standard form. But if I am lucky enough to have my initial point at the point 0, 0, and the terminal point can be anywhere. It can be a fraction, it can be something nice, but it ends up at AB, then I can simply rewrite the vector in component form that is just the point AB, but instead of parentheses, I'm going to put those pointed brackets on it, or you can call it pointed parentheses on it. And that, too, will denote that I have a vector. You'll see all 3 of these over the next 3 videos that you watch me do. Well, let's talk about getting lucky enough to have something that has its terminal point right here at 0. Okay? So suppose that they tell me this blue vector right here from C to D is there. If I could somehow slide this blue line down and to the left so that its initial point lands on 0, 0, and its terminal point goes to point B, which is AB, we call those what is it, congruent vectors, the same vector, because they both have the same length and they're both pointed in the same direction, both of which we'll talk about in just a little bit. And so to get to that form, all I'm going to do is take my terminal point from point D up here, the x-coordinate, and I'm going to subtract off the initial point of, I did that a little bit backwards, let me do this again. The terminal point from my x, and then subtract off the initial point, x value, okay? And then I throw down a comma, and then I'm going to do the terminal, I'm going to go to my terminal point and pick up my y value right here. And I'm going to subtract off the initial, again, terminal minus initial is the key on a lot of this. And what that will do is it slides down this vector and puts it into standard form, which I can write a little bit easier. Let's try that. Let's plug in some numbers. If that's confusing to you, I'm going to plug in some numbers and I'll show you what's going on with it. Now, I'm not going to draw these exact, but I'm going to give you an idea as to what is going on with this. So I have this vector. It's got a terminal point at 2, 3. And it's got it's got an initial point at 2, 3 and a terminal point at 6, 4. Let's just call, I don't know, 6, 4. I'm going over this far. 3, 4. So right here. Okay, so I have a vector that is going this way. I want to find, and they call it the position vector. Okay, so what I'm going to do is I'm going to take that vector and I'm going to slide it down so its initial point is right there on the origin. And see what that vector is. Okay, so to get my hands on that, what I'm going to do, I have my pointed brackets ready to go. I'm going to do my terminal x value minus my initial x value. So that's going to be 6 minus 2. Okay, got to be terminal minus initial. I'm going to do my terminal y value minus, I did an I for that, minus an initial y value. So it's going to be 4 minus 3. And so that gives me the point 4, 1. That makes sense if I was to kind of draw this out, because wherever it lands up, 1, 2, 3, 4, up 1, that's going to be this point right here. And so there's a lot more I can do with this 4, 1 than I can whenever it's written with initial and terminal points. Let's see what all we can do with it, okay? Well, before we get going, the two most important things I'm interested in is the magnitude and the direction. And if you've seen Despicable Me, this isn't going to be anything new for you. It's going to jump slides. I'm going to have to go back. I'm going to have to hit it again. But there's this guy. I know you're not going to be able to hear it. It's playing on my speakers in the back of the room. But this is from the first Despicable Me. And this is the villain in Despicable Me 1. His name's Vector. And he really prides himself that he is able to commit crime with both direction and magnitude. And in this scene, Gru doesn't really care that he can commit crime with direction and magnitude. But the lack of interest Gru has, Vector gets a little bit more excited about it. And he's really excited about it. And so I remember watching this movie for the first time whenever I was in a movie theater, and of course this came out after I became a math major and the math nerd that I am today, and I am just sitting there laughing so hard at this Vector guy because he is speaking the exact truth as to what we're most interested in with vectors. We're interested in the magnitude and the direction of it. And so he was right on with it. So there was some math guy or some physics guy back behind the scenes that was just really loving all that, and I appreciated it at least. And so we have some formulas to help me get that, help me get the magnitude and the direction. Okay. Now remember, magnitude is going to be the length of this vector right here. And what I want to point out is that this vector, if it's in standard form, it is pointing directly at this point AB right here, which means that I went A units to the right and B units up. which means I formed a right triangle, which means that a squared plus b squared equals c squared. Well, in this case, c squared is going to be the absolute value, or not the absolute value, I'm sorry, the magnitude of v. So if I solve this for the magnitude of v, it is simply going to be a squared plus b squared, okay? But I have to have it in this component form going forward. Now the direction angle is going to be a little bit trickier whenever I work this out, okay? Now it says the direction angle is equal to the angle formed with the x-axis or with the y-axis, depending on the application. We'll do one with the y-axis in a later video, but for now, we're just going to assume the x-axis, okay? And I just erased all that. I shouldn't have. Okay? So I just have A and B right here. A and B, it formed a right angle. And I'm looking for this theta right here. Now, I do know what the magnitude of V is. I could easily find it, but if it tells me what A and B are, like it does, like it says it's going to, it gives me this component form, then I'm dealing with the opposite side and the adjacent side, making it so that I have tangent theta equals the opposite B over the adjacent A. My direction angle is just simply going to be that theta. So if I take tangent inverse of both sides, then I will end up with tangent inverse B over A. We have to be careful with this. Okay, I'm going to put a little star by it because you'll see why. You'll see. I don't want to ruin my big surprise ending for you. As much of a surprise ending as we have in the fourth quarter of the free conference. Okay, so we have this, we got this vector. I'm wanting to find the magnitude and direction. And I'm starting at the point -8, +1. It wants me to actually draw the vector. So I'm going to draw both of them. -8, 1, 2, 3, 4, 5, 6, 7, 8, +1. So it starts here, and it goes to the point -2. Oh, yeah, that's right. -2, 1, 2, 3, 4, 5. So this is a cool little trick right here. If you have these capabilities, is that I think that the first order of business is going to be put everything in the component form. Make it so it has the pointed brackets on it. Okay. Remember, to get the pointed brackets, I'm going to do terminal minus initial right there. So I'm going to do -2 minus a -8. And then to get my y component on my component form, I'm going to do terminal minus initial again. -5 minus 1. So altogether, let's see, if 2 negatives make a positive, last I checked, I get 6, -6. Watch this. This is really cool. I'm just going to take this vector, I'm going to drag it over here and make it so it sits on the origin. Look at what point this is pointing at. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, -6. So yeah, it worked. And the whole reason of doing that is that it's going to be a whole lot easier to find direction, or magnitude and direction, off of this component form, 6, -6, than it is going to be working with these initial and terminal points. Okay? So first up, I want to find the magnitude. Okay? I'll just call this vector V right here. And so to find the magnitude of V, I am going to, it just says simply take the square root of a squared plus b squared. Okay, well that's just going to be 6 squared plus -6 squared. Well, that's 36 plus 36. Square root of 72. Let's act like we're fourth quarter pre-cal students right here and go ahead and simplify this square root. That's going to be 36 times 2, so 6 square roots of 2. My computer screen just glitched. I swear if it turns off, it's really bad. All right. Now, I've got my magnitude. That is how long this line right here is. From its initial point to its terminal point, it is 6 square roots of 2. And you're right, we could have got that by just doing Pythagorean theorem. A squared plus b squared equals my c squared. Okay? Same idea. All right? We're just using that idea with vectors. So next, I want to find my refraction angle. And so I'm just going to take the same A and B that I had earlier, A and B, and I'm just going to put negative 6 over 6. Well, guys, this negative 6 over 6, that is going to be a negative 1. And we know what tangent inverse of negative 1 is. That gives us negative pi over 4, or negative 45 degrees. Okay. A lot of times, I looked ahead for your homework, and they're going to want this angle between 0 and 2 pi. Okay, it just glitched again. My goodness, what's going on? So while I did come down 45 degrees, I want to add 360 to it, and the answers that we're going to match what the book has are going to be 315 degrees, or if you want to stick with the radians, 7 pi over 4, and I'll give you that answer. Okay, last thing to talk about here is we can actually do basic mathematical operations on these. If I'm doing basic mathematical operations on these, it says that I'm just wanting to simply take vector u plus vector v. So I'm going to substitute in right there. I'm going to bring down vector u, 3, negative 2, and I'm going to add it to vector v. And to do vector addition like this, what I want to do is I want to add their components. I want to add the first components together, and I get 2. I want to add their second components together, and I also get 2. And then that is my answer on it. The math for that is really easy. Maybe later this week on the Q&A, I'll show you why that happens. I know I do in a later video, so you'll be able to see it. I want you to do u minus v real quick, and then I'll work it out as well, and then you can come back and we'll see if our answers match. Pause on the video. I get the vector for negative 6 on that. Definitely be looking for those on the quiz. Those will be on there somewhere. Now, we can also do multiplication with these. There's 2 types of multiplication. One is called the dot product. We are not ready for that yet. And the other one's called just a basic scalar multiplication. And so on a scalar multiplication, what we're going to do is we're just going to take 3, all right, for this 3v right here. And if I just plug in my vector v, I just get 3 times the vector 3, 1. I'm going to go ahead and do a quick drawing and show you what's going on with this. So the vector 3, 1 right here is just this small vector. What this 3 is going to do to this vector is it's going to make it so it's going in the same direction, but it's going to be 3 times as long as that current vector. Well, to get that, I just need to simply distribute this 3 right here through it, and I get the vector 9, 3. All right, well, what if there's a 1/2 in front? What's the 1/2 going to do to the vector? Well, again, I'm just going to distribute, and I'm going to leave it as a fraction. You can put a decimal here. I'd be fine with that. And it makes it so that the vector is half as long. It goes to 3/2 and then up 1. So the vector is just this little bitty vector right here. Well, what if there's a negative in front? Well, that would be the opposite of 3, 1, right? You can think of it as a negative 1 in front. That would work. Let me go back to my original blue vector. If I throw a negative in front, what it's going to do is it's going to rotate this vector 180 degrees down into the third quadrant. And so I end up, I just distribute that negative 1 through, I get negative 3, negative 1. And that's where it would land. Again, we're going to skip a lot of the graphing on this, but if you have questions on it, I'd be glad for it to have it make sense to you as we go. Okay. Well, let's just combine all this fun and see what happens. I'm going to let you do this one. This is my last example of the day. You work this one. Hit pause, and I'll work it as well, and then we'll come back. order of operations on this is going to be crucial, okay? Just like with please excuse my dear Aunt Sally, I've got to do this multiplication and distribute this 3 through before I deal with this addition. Okay, so my answer let me double check it real quick. I got 7-2 on that whenever I was to graph it, or whenever I was to work it out. If you're interested in the graph of it, I'll be glad to do that for you at a later time. Just have that question ready. Here is the practice problems I would like to see. I'm trying to pull back a little bit so you guys will work these. But work these, and this will be similar to what I put on the quiz coming up later.